Well, welcome everybody. We're here at some parkland just off of Roberts Road and just upstream of Lake Royal. We've got a small creek behind us and we're standing on a fairly long and steep slope. We're very close to the top of the hill right now. We're going to take one soil core up here at the top of the hill. We're taking another soil core down at the bottom of the hill a little bit later to see if there's any identifiable differences we can see between the two soil types at the two locations. So one of the reasons that we find different soils in different parts of the world, different parts of this park, different parts of this very slope, why the soil 10 feet that way may be different than the soil here, is because of the 5 soil forming factors, which go by the very terrible acronym CLORPT, C-L-O-R-P-T, CLORPT. If you can remember CLORPT, hopefully you'll remember the 5 soil forming factors. It's such a bad acronym that it's actually memorable, so maybe that makes it a good acronym. What does the CL stand for? CL stands for climate. O in CLORPT stands for organisms. R stands for relief, which is just another term for your landscape position, where you are on the slope. P stands for parent material, and T stands for time. So climate, organisms, relief, parent material, time. Those are your 5 soil forming factors. And the differences in those 5 factors from one spot to another make different soils. So when we're digging here versus 100 feet down slope, do you think we're going to find different climate? Not likely. The climate here is going to be the same as the climate down there at the bottom of the stream. So that's not going to be one of the factors that causes any changes in the soil within this park. What about organisms? There might be some subtle changes to organisms, but we're in a pretty consistent forest right here. The trees that are growing up here, the species of trees and other lower plants that are growing up here are probably going to be pretty similar to what's growing down along the stream side. So that's probably not one of the reasons. Relief or landscape position, is that going to change from up here at the top of the hill to down next to the stream in the floodplain? Yes, that's going to be the big change from one spot to the other as we move down our hill slope and dig our second core down by the stream. So our relief will change, so that's probably one of the reasons. If we do see differences, that'll be one of the reasons why. What about parent material? Parent material is the material from which the soil forms, from which it weathers. It's possible we could see some changes in parent material from the soil here at the top of the hill to the soil at the bottom of the hill. Why is that? Well, the soil here likely formed directly from the bedrock below. As that bedrock weathers and decomposes in place, it starts building up soil on top of it. When we get down to the bottom of the hill, we're next to the stream, we might get into the floodplain. In the floodplain, every time the creek floods, some of the sediment that's being pushed along by that water will settle out on the floodplain. So that's a different parent material. That's material that was brought in from the stream rather than material that was just there and weathering from the bedrock that's below our feet, below the soil. So there's a potential parent material change. And then lastly, there's time. Is there a big change in the age of the soil up here versus the soil down there? Perhaps there's a little bit, but I don't think that's going to make much of an effect on the soils that we see. I think the biggest change is going to be relief or our landscape position, and the second biggest one is going to be parent material. Now, when we start digging with our auger, which is basically just a big hand-powered drilling device, this is going to be what we use to extract our core of soil. What are we likely to see as we go from the top of the soil down to the bottom? This is one of my bigger augers. It can go down about 6 feet. Not to say that we'll go down that entire depth. As we go through the soil, you see that there are changes. Soil is like a layer cake. You'll find unique layers as you start from the top and progress your way down to the bottom. Those layers are called soil horizons. Each unique soil layer is called a horizon. And we've got several of them. There's the O layer, the A layer, the E layer, the B layer, the C layer, and the R layer. We call them O horizon, A horizon, E horizon, B horizon, C horizon, R horizon. And that's the order that they come in from top to bottom. You won't necessarily see all of those layers in each soil, but you will see at least some of them. What is the O layer? That's an easy one to show. It's the loose organic matter right on the soil surface. A lot of people don't even think of this as part of the soil, but we do, as soil scientists, consider this to be part of the soil. These leaves and twigs and other dead, decaying organic material are decomposing on the forest floor right here, and they're breaking down and becoming soil humus, which becomes part of the soil. So we do consider that loose organic matter to be part of the soil. But generally when people thinking soil, they're thinking of the stuff that's below the surface. That's the A horizon first, A horizon is just a common name for topsoil. If you've ever bought a bag of topsoil from Home Depot or a nursery, basically what you're buying is bagged up A horizon. Below the A horizon, we can sometimes find an E horizon. The E I like to think of as exit. It's the layer that everything has washed out of. So as soil forms around here, it tends to build up quite a bit of natural acid. And that natural acid tends to wash through the E horizon and strip a lot of materials out of it, wash a lot of those materials away. Things like organic matter tend to get stripped out of the E horizon. Things like iron oxides tend to get stripped out of the E horizon. And what's left behind is kind of a pale gray, washed out looking colored layer. That's the E horizon. Sometimes you'll see that in soil, sometimes you won't. I give it about a 50-50 around here. Below the E horizon, you have your B horizon. That's where we tend to find the most clay. So it's usually the stickiest and densest feeling of the layers. That's also usually where you find the most colorful soils. Generally, where there's a lot of clay, there's a lot of iron oxide too. And iron oxide will give the soil that red, yellow, or orange color that we typically see. Below the B horizon, there's the C horizon. That's where the clay starts to drop out. Oftentimes, we think our soils are really clayey here, but if we dig down deep enough, we get below those clay layers into the C horizon, and the soil will start getting looser, sandier, lighter, grittier, just much less sticky because the clay tends to accumulate in the B horizon and reduce as you get down into your C horizon. And then below that, we probably won't hit it today, but you can get an R horizon. What is R? Rock, solid rock. Basically where you have to stop digging because you're hitting rock, that's your R horizon. So let's see if we can find some of those layers with our soil auger. I'm gonna just give it some all right, one more twist. It looks like we got a good little sample of the top couple inches layers. So the A horizon, what do you look for when you're looking at the A horizon? Well, oftentimes it's color. You don't have a very thick A horizon around here, but generally the A horizon is going to be the darkest of your layers, dark brown or black. And the reason for that is because it has lots and lots of decomposed organic matter in it. Soil humus is what that stuff is called. And soil humus generally tends to be dark brown or black. Soil humus is very important because it is a source of nutrients and organic carbon to the critters that live in the soil, as well as to the plant roots. So our A horizons around here, in this part of Virginia, tend to only be about 2 or 3 inches thick. So they're not particularly large, but those 2 or 3 inches contain a lot of important soil material, and they are also the biological powerhouse of the soil. That's where we find the most microbes and also the most living roots, because they're all looking for that decomposing organic matter. We'll see if we can get down a little bit deeper here. We've got some roots and rocks in the way, but hopefully we'll be able to break through them. You can hear them crunching there. Now as we work our way down, we'll see if we can find that E horizon, but I have a feeling this is one of those 50% of soils that don't have an E horizon. I think we're just going to get right down into the B. How can you tell? Well, again, if we had an E horizon, we'd see real pale colors, but what I'm seeing here is a soil that's getting a little bit more orangey and a little bit stickier, a little bit clumpier, which tells me that we're seeing an increase in clay. And if there's an increase in clay, that's a sure sign that we're down into our B horizon. I'm going to lay all these layers out into this piece of cut off gutter that I have lying on the ground. So hopefully we can kind of poke through these layers after I'm done digging them out and show you the differences a little bit more clearly. Yeah, it definitely looks like we're down in our B horizon now. Let's see if we can find anything below. Now, B horizons in Virginia can often be fairly thick. So while you may only get 2 or 3 inches of A horizon, you might get 2 or 3 feet of B horizon. We tend to have a lot of clay in our local soils, and therefore very thick and deep B horizons. We're down about 2 feet now, and it's definitely getting a bit easier to dig. And one of the reasons for that is at this depth, we're actually down below most of the roots. Even though we're in a full-grown forest here, and we've got very large, 60, 80, 100-foot tall trees, for the most part, the roots of these trees are going to be found in the top foot of soil. And again, that's because the little tiny roots, the feeder roots that are really taking in water and other materials from the soil, they want to grow up to the A horizon, because the A horizon is where you find your nutrients. They're not going to get nearly the amount of nutrients down below, lower in the soil. So our trees around here tend to have a very big root system, but a shallow root system. They spread their roots out wide and flat, just a few inches to a foot or so underneath the soil, rather than going down real deep. Now we're getting in the C horizon. So I'll bring a handful of this stuff over. We still have that orangey color, but it's getting a lot lighter. It's not nearly as dark as it was when we were down in our B horizon. So hopefully this shows up on the video. In person, you can see it pretty well. There we go. So more of the same. By the time you hit the C horizon, what we're probably going to find is the rest of this hole is just a continuation of the C horizon. I would be surprised if we hit the R horizon within a reasonable depth here. Oftentimes around here, on an older soil like this, you might have to dig down 10, 15, 20 feet before hitting bedrock. So I don't think we're going to hit it here. But I'll take a couple more scoops to see if we can see any changes. But I have a feeling we're pretty much in a very consistent span of the soil right now. We're not going to see a lot more changes in soil horizons at this point. The only real change I see is that the soil is getting even a little bit lighter, a little more dry and crumbly, and we're beginning to see a few pieces of saprolite, which I'm pointing at with my thumb there. So again, those are those little pieces of material that are not quite soil, not quite rock. They're somewhere in between. I'll see if I can get a better piece of saprolite. If you were out here with me and we were doing this hands-on, I'd be doing something called the saprolite challenge, where I get a hard piece of saprolite and see if you have the hand strength to squeeze it and pop it between your thumb and forefinger. Obviously we can't do that right now, but I was going to see if I could find a good piece of saprolite to just sort of show you what that was like. These are looking pretty soft though, so no good saprolite challenge pieces just yet. Maybe here's one. So again, it looks like soil, but it's still pretty hard like a rock. But hopefully if I squeeze it hard enough between my thumb and forefinger, it'll break apart. So that's saprolite. It's rock that's in the process of decomposing into soil. The soil's feeling very loose and dry down there, so we're definitely deep within the C horizon now. It's getting even lighter. Nice color change here. I'm just going to do one more auger's worth, and then we'll call it for this hole. Nice light colored stuff. I'll bring a handful of it out. It's getting to be almost kind of an orangey gray color now. It's quite a bit different than what we saw up above. All right. Well, that's it for this soil. I think we might take a closer look at some of the layers as I've laid them out in the empty gutter here. And then we're going to head downhill to take a second core closer to the stream and see if we can see any noticeable differences between this soil and that soil. Okay, so here we have our soil core all laid out in our empty gutter. And hopefully this will help you see the color differences and the textural differences between the layers as we move from the top to the bottom. So generally you can tell where the A horizon starts and stops based upon color. It's usually the darkest layer, and as you get down into your E or B, in this case we move straight to the B, we skip over the E, you'll see that the soil either gets lighter if we're moving into our E horizon, or it gets more red, orange, yellow as we're moving into our B horizon. You can definitely see a transition here, right around 5.5 inches. And I'll grab a little handful of the A horizon and the horizon that goes just below it. And from there, you'll probably be able to see pretty clearly that color transition. When they're right next to each other, it's pretty obvious. So here's our A horizon, here's the start of our B horizon. What you might notice too is the B horizon is a little bit chunkier. That's very common as well too, because it generally has more clay, so it kind of makes bigger chunks than what you would find in the A horizon. Now, as we move through the B horizon, I see there's another little change here right about 17, 18 inches. It looks like the soil starts to get a little bit lighter in color, still orange, kind of an orangey brown, but there's definitely a change in color. So this is the top part of the B horizon, this is the part below 17 inches. It starts getting a little bit lighter, a little bit more washed out looking. This is probably a transition layer between our A and our B horizons, our B and our C horizons. As we start to lose a little bit of that clay content, the soil is going to get a little bit drier because clay attracts a lot of water, whereas the sandier, looser C material just doesn't hold water as well. So a lot of times our B horizon will be a little bit darker because it's a little bit more moist. And we can see a real color change down here at about 36 inches, 3 feet, compared to what we have on top. You can see those two colors right there. So this is lighter than the top of the B horizon. This is probably deep within the C horizon. You can see that color change right there. It's just getting lighter and a little bit grayer. And you can see the C horizon deep down below, it's just like powder. It's really, really loose. It doesn't stick to itself like the B horizon does because it doesn't really have any clay in it. This is sort of a transition zone between the two. There's not a lot of clay here, but enough that you can make a little soil ball out of it. And as we go deeper and deeper, we just see more of that loose, light, powdery C horizon. Very low in clay, very loosely bound together, very powdery, very dry.